This is a Key Stage 3 light video looking at refraction of light through a glass block. The first thing I'm going to do is draw around my glass block. Like so. I'm going to remove that and I'm going to decide where I'm going to have my beam of light go into my glass block, and I'm going to go for over here. So there is my incident ray, and give it the arrow to show the direction of light. And I'm also going to set up, using my protractor, the normal line. So I line up the base line of the protractor and the center point there with where the incident ray hits the block. And I do my dash, and then I can do my normal line at 90 degrees, and I'm actually going to take my normal line through the block so we can look at the angle of refraction like that. Okay, so let's put my light into the block. So I'm going to have my beam of light going along where I've drawn my incident ray, and I'm going to position my block exactly where I drew around it. And we can actually see, this is quite interesting, there's a small amount of reflection over here just because the edge of the block is shiny. Okay, so I'm going to do what I've done before on the reflection videos, and I'm just going to put a cross there so I can look at the reflective angle there, and then I'm just going to put a little dash just where the light comes out of the block on the other side, and then again a cross and maybe another cross there to show the ray of light as it comes out of the block. Okay, now if I move my block to one side, I can join those lines. So if I join first of all this small amount of reflection that we had off the edge of the block. Okay, then I had the beam of light as it exited the block, and we can notice here that the line of the light as it goes into the block and as it exits the block, they are completely parallel. Okay, and that's important. And then as the light travelled through the block, if we just line it up again, we can see this. As it travelled through the block, it's quite hard to see it through the block, but it bends across the block just here. Okay, so let's have a look at joining that together. At the point where it went into the block and the point where it exited the block, that's what happened to the light inside the block. Okay, the light bent, we say it refracted. Okay, let's look at measuring some angles now. So the angle of incidence is over this side, and that is measuring from 0. Just line that up properly. That is 48 degrees. And then if you watch, so I have my protractor like this, I'm now going to turn it around, measure from that normal line again, inside the block now, and that's exactly 30 degrees. So it's not like reflection where the angles are the same, the angles can change. Okay, and what I can do is I can look at the angle of incidence and the angle of refraction as it leaves the block as well. And I'll put my normal line here. Again, going through that boundary at the block. And here I've got my angle of incidence and angle of refraction here. Okay, so let's have a look at measuring that. So angle of incidence for this one is 30 degrees. And angle of refraction for this one is 48 degrees. Okay, now if I change the angle that we have the light go into the block at, so I'm going to go at a wider angle this time. Okay, and I shall draw that beam. So we'll go in at a wider angle. Okay, so now I'm going to be measuring that angle all the way from the normal line to the ray of light. There it is. And let's put the block in place. Got again that bit of reflection as it comes out of the block. I'm not going to draw that this time. And then just as it leaves the block, and sometimes it's really hard to see where it's actually coming out of the block, so I'm just going to curl the paper up just to see where it's leaving. It's actually just slightly further along than I imagined. Okay, and there I'm going to draw my crosses. Okay, move that block out of the way. Join these lines together. Okay, and then through the block again. Okay, and then we can have a look. This time I'm just going to look at the angle of incidence and the angle of refraction. Okay, just this one here. So let's use the protractor. And we're looking at an angle of 70 degrees for the angle of incidence, and the angle of refraction is 38 degrees. Okay, so the angle of incidence has increased and the angle of refraction has also increased. Now we've got to talk about what causes this to happen. So if we look at particles here, this was the light travelling through air, so the particles are in a gas form, and then as they go through the glass, the particles are in a solid arrangement, so the particles are much closer together. Now, we talked about in the properties of light video that light actually doesn't need a medium to move from one place to another, and these particles actually slow the light down. So as the light goes through the air, it's reasonably fast, and as it goes into the block, it actually slows down. These particles are blocking its path, and the beam of light slows down, and it bends as it goes into the block, almost trying to find a quicker route out rather than continuing on this path, which would take a long time. It's almost trying to take a quicker route out, and we'll talk about that on the flashcard in a moment. So we've looked at how we can draw angles of incidence, use the normal line, and measure the angles of refraction. Let's have a look at the summary on the flashcard. Okay, so the angle of incidence does not equal the angle of refraction. Light refracts, which means it bends at the boundary between different materials. Here the light bends as it enters the glass block from the air. When the light hits the glass block, it slows down as the particles are closer together in the solid than in the air, and we can see this from the particles drawn on this diagram. Now, to explain why the light bends is the challenging part. So we've got a car here, and we've got to imagine that when the car is in the air section, it's like driving on tarmac. And then when it gets to the glass block section, it's like the car is just about to drive onto some sand. Okay, as that first wheel that's closest to the sand, the glass block, hits the glass block or the sand, that particular wheel slows down because it's hit that resistance of the particles of the sand. So all of the other wheels of the car are still going at the same speed, so the car naturally twists round, which is what's happening here. The light twists as it refracts and bends at that boundary, okay? And we try to explain it thinking of this car. And as the car comes out, again, that first wheel will hit the tarmac over here in the air much quicker, than the other wheels, and it will go faster, twisting that car back exactly in the same trajectory as it had originally. Okay. Both light rays in the air are parallel to each other. So this beam here and this beam here, they are parallel. So the car, the light, is continuing on the same journey that it started on originally. Hope you found that useful. Thank you.